Hello, everyone. Welcome back to the 8th episode of the podcast, and it's just me this week because I had guests lined up, but it didn't work out. They'll still be on next week. It's fine. Don't worry. It's gonna happen. So yeah, it's just me this week. You're very lucky. I've taken some time out of my incredibly busy schedule to be with you. So uh, yeah, basically, I put out a Instagram question thing, and I asked people to ask me things that exist in Pokemon and to try and explain them scientifically. And you're probably like, why are you suggesting this? There's no, how do you know? I have Google. Why would I not just Google it myself? And the answer to that is, well, you didn't, did you? You're here. So take that, basically. So I asked people to ask me questions, and I've got 3 questions I'm going to answer. There's also 2 smaller questions, and the first one was, why did I do a chemistry degree? Or how did I get through a chemistry degree? And the answer is that I hate myself. And the second one is, how does Hoppip fly? And I'm probably going to make a video on that because honestly, it makes no sense, but it does make sense. And you'll see that's a theme that runs through this recording, is that it doesn't make sense, but it also does make sense enough at the same time to kind of be like, I get it, but it's not happening. So yeah, I'll crack on with the first one. And the first one is from, let me just find it on my phone. It's incredibly professional. I should have got this up before. Um, Basically, the first one asks, how does Guzzlord even work? And it's a good question because how does it even work? And I've prepared a brief speech. So settle yourselves in and enjoy. So Guzzlord. So in Pokemon Sun and Moon, if anyone's not aware, a new mechanic was introduced, and with this mechanic, a new variation of Pokemon was also introduced, and basically there was the ultra wormhole other dimension thing that was introduced, and these Pokemon that come from this other dimension are called Ultra Beasts, and they're not like any other Pokemon that we'd seen up until this point. So they had basically were very alien looking. Lots of them were very big. So Guzzlord is very big. Celesteela is unfathomably large. I will just, if you don't know how big Celesteela is or how heavy Celesteela is, look it up. It's kind of terrifying. But yeah, like I said, one of these is Guzzlord, and Guzzlord's description on in its Pokedex entries, and I use Bulbapedia for a lot of my information, so shout out to them. It's a creature that's said to eat whole buildings and mountains in one go, and despite its appetite, no droppings have ever been found. It is speculated to convert everything it consumes into energy, and with no waste left over. And as a scientist, when you hear energy with no waste left over, you're like, no. So I looked into it and saw how feasible Guzzlord actually is. So obviously we don't have Pokemon in our world, so I decided to see just roughly how feasible it is. So the easiest explanation that I came up with, and by easiest I mean simplest, is that, and I have written down here, Guzzlord's ability to consume is a product of our capitalist society in which consumption of all single-use items and media is so easy. There is no reason to stray from this philosophy. I don't know quite what was troubling me so much at that point, but it's basically a walking black hole is what they're suggesting it as. So, I mean, if you're not familiar with black holes, which is fair, because even the people that know a lot about them aren't fully familiar with them, I'll give you a brief explanation of how they work, basically. So we know a lot about black holes. They are basically gravity traps that distort space-time, which are one and the same thing if you were unaware, in which a sufficient mass is achieved so that nothing is theoretically able to escape its gravitational pull once an event horizon is crossed. So an event horizon is basically an imaginary line where anything that goes past that line is lost to the black hole and can never return. And unfortunately, this is where our knowledge of black holes basically just goes away because we don't know what happens after this because it never comes back. So we kind of just have to guess at this point. But if our scientists are good at anything, it's making educated guesses and passing them off convincingly enough to convince you that they are in fact real. So it's true that Guzzlord and black holes do have initially a lot in common. They're both black for a start, although black holes technically aren't black, but that's a different thing. They also ingest large amounts of matter, seemingly with great ease, and nothing ever comes out again. But that's basically the only thing that's similar between the two of them. So, black holes are dense, and basically that's a cataclysmically large understatement. Calling a black hole dense is a little bit like calling the Atlantic Ocean a small puddle. And black holes are, as I said, very dense, and they're so dense, in fact, that even light is not able to escape once it enters a black hole. So just let that sink in for a second. It's quite an important thing. So once it crosses an event horizon, light, again, any actual physical matter as well cannot escape. We don't know where it goes. But the fact that light can't escape presents actually quite a big difference between something like a black hole and Guzzlord, in that Guzzlord, although is on a computer screen, is able to be observed in the Pokemon universe. The way that we study black holes up until recently has been through very indirect methods. So I think it was 2, maybe 3 years ago now, we finally took a picture of what we could consider a photograph of a black hole. And even then, we don't actually see a black hole because there's no light escaping. What in fact we see is a large, incredibly hot kind of flat disk of matter called an accretion disk. And this is made up of fragments of planets and stars and dust and everything else that's annihilated by the black hole, and basically the gravity of the black hole stretches it out into like a long string that then orbits the horizon of the black hole. So we can assume that Guzzlord is not dense enough to trap light, and therefore is not dense enough to be a proper black hole. But surely it has to be, somewhat dense enough to act similarly to a black hole to be considered even remotely like one. So as I mentioned, black holes are denser than month-old Christmas cake. So for Guzzlord to be able to inhale matter in the same way, it has to have at least a similar density. So obviously it's not going to be as dense, but I'll do the maths, or I've done the maths, and I'll tell you about it, to work out roughly, is it feasible? So Guzzlord's Pokédex entry says it's 5.5 meters tall, which is a big boy, and it has a weight of 888 kilograms. If you're unaware, if you actually go onto Pokemon's website, once you get past a certain point, and even in the lower amounts, Pokemon don't really like having very variable weights and measures. So there will be commonality, like common weights and heights that lots of Pokemon share, and there'll be very little in between them. If you ever fancy looking that up, it's all on Bulbapedia, like I said. So for ease, we're going to assume that gravity works the same in the Pokemon world as it does in our universe, and say that its mass is also 888 kilograms. And you're probably thinking that they're the same, and on Earth they are the same. It's because the gravitational constant on Earth is roughly 1. But the reason that I have to differentiate the two and like kind of qualify that they're the same thing is that they are very distinct properties, and they are used interchangeably in everyday speaking. When you weigh yourself, you're measuring your mass relative on Earth. You're not measuring, you're not measuring your mass on the moon. So your weight on the moon, sorry. So your mass is consistent throughout. Your weight changes. That's why when astronauts go to the moon or go to space, they seem like they weigh a lot less, because they physically do weigh a lot less, but their mass is constant. But like I said, for the basis of this, we'll assume that its mass is consistent. So if we assume that Guzzlord is perfectly spherical, which is a classic physics assumption you do to eliminate variables like arms or faces, we can assume that it's spherical, which basically you'll see my point, and it's close enough to assume that. It has a volume of roughly 522.7 cubic meters, which is very large. So from this, we can work out the density. So density is just its mass over its volume. So if we work out the density of Guzzlord, its density is 1.699 kilograms per meters cubed, which, without context, means nothing. But that's not dense at all. In fact, it's incredibly not dense. And it's so not dense that it's roughly double the mass density of hydrogen gas. So Guzzlord will be a little bit floaty. If we say, in contrast, Black holes have a rough density of 2 times 10 to the 19, which is 2 with 19 zeros after it, which is just, as you can probably gather, a little more. So from this we can say with confidence, I've written with confidence on here, we can say with categorical confidence that Guzzlord does not have the properties of a black hole. It's closer to a helium balloon than it is a black hole. So now we know it's not a black hole. How can we explain its ability to make things seemingly disappear, other than magic, which we're not going to go for? The first place to start is to decide whether or not the matter is being converted into energy, which is one way to get rid of matter. And I won't go into details, but I'll say most likely it's not, for many reasons. And it's definitely not hot enough to perform nuclear fusion, which is the combination of atoms. And nuclear fission seems unlikely, which is the splitting of atoms, because it's not glowing like a radioactive jack-o'-lantern. The other alternative is annihilation. So annihilation is where you get matter and antimatter, and they smash into each other, and they get rid of each other, and it turns into energy. This is also unlikely, because recombination of that much matter would cause moderate to severe frying of any organism in a continental radius, and this is a game for children, so that probably wouldn't be targeting their main demographic. So we have one last possible explanation, and it's that Guzzlord is the host for a localized wormhole, and not just any kind of wormhole, it's what's known as a traversable wormhole. So a traversable wormhole is just another name for basically like a movie wormhole, where you step in at one point, and then you step out at a different point in space. Theoretically, there can be any distance apart that you require. So wormholes have a similar problem as black holes, where they're only formed under very extreme circumstances, and wormholes are not even known to exist in nature. So wormholes are purely theoretical at this point. And in this case, the reason for that is massive amounts of energies are needed to create a wormhole, and that doesn't even touch on the ability to sustain one. So if we focus purely on the energy requirements to make one, if you give a rough idea of how much energy is needed to create a wormhole the size of a grapefruit, which again isn't much help for a building, it would require roughly 1.12 times 10 to the 42 joules of energy. And again, with no context, that means nothing. So it sounds like a lot though, but that's just because it is. This is as much energy as the sun produces in about 100 million years. So it's a decent amount. It's again a little bit of an understatement. But we can actually work out how much matter, like how much stuff we need to actually equate to this amount of energy. And we can use Einstein's relativity equation, which is E equals mc squared. So that's the equation we use to basically work out the relationship between energy and mass. And if we work this out, c is the speed of light, if anyone wondering, it comes to 1.33 times 10 to the 25 kilograms. And again, no context, so I'll give you some. And this is roughly 100,000 million times the mass of Mount Everest. So basically, there's no feasible way that Guzzlord can actually achieve the annihilation or intergalactic transport of matter in our universe. But the key thing really is that it's not in our universe. It's in Pokemon's universe. And even then, it's in a parallel universe to the actual Pokemon universe. So Guzzlord and other Ultra Beasts existed in an alternate or parallel universe, which is vastly different to our actual physical universe that we live in as human beings. So I'm sure that canonically there's a reason and a logic to why these things can happen. But if we applied real physics, which I did, Guzzlord cannot do the things that it claims that it can do. But to be fair, ultimately, Pokemon isn't real. So they can just do what they want. And yeah, thanks for Karim who submitted that question. I'm hoping I exhaustively explained that Guzzlord is a fraud and we should stop using it. But it does have the highest HP of highest HP stat of any dark Pokemon in the whole of Pokemon. So I guess that's something. So this next question is from Pokemon 16 on Instagram, and she asked, how could Mega Evolution work? And so here was what I got. So Mega Evolution is a phenomenon that exists in Pokemon universe and is basically a temporary transformation, where Pokemon become more powerful, and this transformation is normally associated with some kind of physical appearance change. So physical appearance changes happen all the time in nature. Can be seasonal changes like shedding hair or shedding your skin, or deers when they like kind of molt their horns and they go all red and metal. Not actually metal, they go like blood color and it's don't worry. And there's also shorter term changes like a chameleon or a cuttlefish changing color, or when the octopuses like change color and look like coral and stuff. And these all basically provide some kind of like survival advantage, whether it's against environment or against predators or whatever. But Mega Evolution is not that. It's more than a superficial change. In fact, the superficial change is basically just a secondary thing, and it can be seen by the fact that their stats change, or in some cases their typings change, and that Pokemon undergo these changes when they evolve. So for this reason, Mega Evolution is more similar to like a metamorphic change that's seen in, say, insects or frogs. So the first thing that we kind of need to talk about is where it came from. So there are two stories in the Pokemon games about where it came from. So the first is that according to Zinnia's grandmother in Pokemon Omega Ruby and Alpha Sapphire, Rayquaza was the first Pokemon to ever Omega evolve, and that Mega Evolution was discovered by humans when Rayquaza did this. And then there's also a conflicting one, which I'll talk about in a second, but just from the Rayquaza front, it comes from space, so it doesn't really help. There's also very little information about it, as Rayquaza is a legendary Pokemon and therefore not intrinsically tied to a trainer, so I will leave that for now. And then we'll go on to the second origin story, which is that Lucario was the first Pokemon to Mega Evolve. So Pokemon generally aren't basically shown to be good without trainers. I know in the anime they kind of are, but quite often in the games, like you were told to take a Pokemon under your wing and then train it and then make it better. So noted scholar Professor Sycamore said that Mega Evolution can only be achieved if there is a strong bond between a trainer and a Pokemon. Initially, this kind of just sounds like one of those, Pokemon taglines to make you take care of your Pokemon in game and use like Pokemon and me and stuff like that. But it actually does explain something, which I think is quite important, and I will talk about that now. So metamorphosis is basically a process where organisms make drastic physiological changes in a number of stages until they reach maturity, and this is basically how evolution works in Pokemon. For most Pokemon, obviously some Pokemon don't evolve, but in reality, some animals in the real world don't change drastically throughout their lives either. They just get bigger. So we're talking about not growth. So for example, humans do not go through metamorphosis. We grow bigger and we remain very similar. Metamorphosis is where you go through, an insect will be like a butterfly, for example, starts off as a caterpillar, becomes a butterfly. That's metamorphosis. It's distinctly physiologically different, with different abilities and different properties, and usually accompanied by a physical appearance change. So there's one other similarity which kind of helps this out, is that Pokemon all come from eggs. So do insects. So it's not a huge bit of information, but it's something else that's common between them. So I know I've basically said that they're similar. Like, how could it actually be physically possible? And to understand this, we need to understand how metamorphosis kind of actually works. So metamorphosis, as with most things in the body, is caused by hormones. So hormones are basically a catch-all term for any signaling molecule in the body that elicits some kind of response in another part of the body. And in insects, hormones are released, and this causes metamorphic changes to begin. And this kind of makes sense when they transform in response to temperature or other environmental changes. But metamorphosis in response to friendship seemingly makes no sense. But, and now here's where you have to go with me. One class of hormones in the body is endorphins. So you've probably heard of endorphins as like the happiness chemicals in your body. So if you eat chocolate or you're in love, for example, you have endorphins released. And for some people, those are one and the same. When you experience any kind of joy or euphoria, endorphins are released, and studies have shown that friendship can induce endorphin release. So it is possible that once a sufficient level of friendship and therefore endorphins is reached, mega evolution could happen as a metamorphic change. And although the timescale for metamorphosis in the games is obviously much faster than it could be in real life, we can kind of ignore the time change, as we're not, obviously, mega evolution is not a real thing. So I'm just suggesting ways that it could be initiated. I'm not necessarily explaining the timescales, because even I'm not pedantic enough to care that much. So I've basically said that it's comparable to metamorphosis. It could feasibly happen. There is a mechanism similarity between the two, but the big thing that mega evolution has is that it's reversible. So once a caterpillar turns into a butterfly, it doesn't go back. It's always a butterfly until it dies. Mega evolution is a temporary change that, it reverts back to its normal state. So, can you reverse metamorphosis? And the answer with basically everything else I've said here is, yeah, kind of, pretty much. So there was a study in 1985. I looked at actual papers for this, actual science papers. They found that a coral planula larvae, and I've got a direct quote here, are re-stressed. If they are re-stressed within 3 days of settlement, they can retract all tissue from the skeleton and revert to a motile planktonic form resembling the initial larval stage. And I'll be honest with you, initially I didn't really know what that meant either. But basically, if you simplify it, if you put the coral under significant stress, it can reverse its metamorphosis back to how it was before, and then undergo it all over again, and be perfectly the same and happy. So when a Pokemon Mega evolves, it returns to its normal state if it's knocked out, or if it's returned to a Pokeball. And if I'm being honest with you, if I was turned to pure energy, or beaten within an inch of my life in combat, I'd probably consider that being stressed too. So there is a natural precedent for reversible metamorphosis. Again, you have to stretch it a little bit, because I'm not sure if this coral can do it multiple times. I'm not sure if it gets any better when it's done it. But we have to go with what we've got. There's one thing I haven't discussed, and it's the fact that you need a Mega Stone to allow Mega Evolution. And I tried to work this out and rationalize it in many, many ways, but most of them don't make sense. Maybe it provides like a kick of energy, but that doesn't really make sense because it's not. If it was, say, attached to the Pokemon, that may kind of make sense. We know that energy works differently in the Pokemon universe because of the whole like Dynamax thing. Like that Dynamax energy is, it's a thing. It like permeates through the region of Galar and stuff like that. So we know that energy works a little bit different in the Pokemon universe, but I won't go into that because I can't be sure. The only thing I could think of is that it initiates some kind of hormonal change not within the body. And the only real thing that we can say about this is that pheromones function similarly to hormones but travel outside the body. Lots of animals produce pheromones, usually in reproductive capacities. But this could, in theory, induce a mega evolution in a way that does not rely on friendship, which would kind of explain how you can mega evolve a Pokemon that you've never actually used before. which, you know, helps. And I know it's a stretch, but I did the best I could. And if you think I can do better, then congratulations. I hope it makes you happy. What a sad little life, Jane. So, yeah. In conclusion, is it feasible? Kind of. Yeah, it is actually. It's not actually that far-fetched. The leek bird. The basis for reversible metamorphic change does actually exist in nature. It's been studied by real science people, so, that's good enough for me. This next submission was from a fan of mine called Toby. I think he keeps birds or something. And he asked me, how does Haunter lick people and then they convulse and die? So I decided to focus on how the convulse and die part, not how does he lick people, because that's far too difficult to work out how a ball of gas has a tongue. So we'll focus on the poison parts. So there are many different types of poisoning, and they affect many different kinds of things in your body. So there are poisons that can give you cancer, for example. There are carcinogens. These carcinogens work in a number of ways. Some of them combine with your DNA, and they cause mutations and things like that. They are still technically considered poisons, but they are more long-acting poisons. So that rules that class out. Anything that takes, more than a few exposures and a large amount of time, anything more than, say, an hour, we could rule out that. And that rules out a very large amount of these kind of toxic substances. So that rules out anything, anything like that. We can also rule out anything that isn't a gas. So again, that rules out an absolutely massive segment of what's left. So anything like any metal poisoning, so mercury poisoning, lead poisoning. You're not getting a block of mercury or lead in a Haunter. It's just made of gas, so it would just not work. We can also rule out predominantly anything liquid, just because of ease. Really, there aren't that many liquid things in the things that we've ruled out already. That are left. Sorry, after we've ruled out the things we've ruled out already. So then the next thing I focused on was the symptoms, as you do. So it says very distinctly that it causes convulsions and then death. So after Googling, and I'm probably on a register at this point for dangerous war criminals, what causes convulsions and things of that kind of thing? I settled on the fact that it's probably some kind of nerve agent. And so a brief history of what nerve agents actually are. So nerve agents have been around for a while. At most maybe 100 years. And they come in a number of different kind of guises, but they're all roughly the same thing. So nerve agents they're also called nerve gases. They're organic chemicals, which means that they consist of nothing. They only have they don't have metal in them. Basically, that's all an organic means. And they come in different variants. Imagine different brands. So they're all roughly the same thing. Like you go to the shop, you see there's lots of different brands of bread. They're all bread, but they all do very different things. But they all do, they do different things, achieve the same goal. They all make a sandwich. Let's put it that way. It's an incredibly long-winded metaphor, but yeah. But you don't want to eat these. That's a key thing. So you have different chemical agents that target different parts of the body. Nerve agents, as the name suggests, target nerves. So they specifically target the nerve synapses, which are the gaps between your nerves. So the way that nerve synapses work is that there is physically a gap between them. It's obviously an incredibly small gap, but it is a gap nonetheless. And the reason that there's a gap is you have to have this gap to allow your nerves to have both an on and an off function. So nerves are very binary. They either are active and doing things to make movement or send signals or whatever, or they are off, in which case they are doing nothing. Think of it, it's literally just like a light switch, basically, but it's a light switch that controls parts of your body. So there needs to be a way to get the signal from one side to the other to make things happen. And these things that go across are known as neurotransmitters. So there's lots of different types of neurotransmitters. In the body alone, there's several that do things, and they all do slightly different jobs, but all achieve the same kind of thing. It's very similar to what I was talking earlier about hormones, where it's a catch-all term for things that do similar jobs but slightly different variants of the job. And the one we're going to focus on for this example is called acetylcholine, which you may have heard of, you might have not. It's kind of irrelevant to the argument here, but acetylcholine is the thing that travels across a lot of your synapses. So, like I said, it's very binary, so it's on or off. So once it's turned on, you need a way to turn it off. So these are released from one side and travel across the little gap. And then once they get to the chosen, the designated end point, they do their job, they move the muscle, they inhibit the response that they want, and then there is an enzyme, which is just a big protein kind of glob that soaks up the acetylcholine and takes it all in, and then once it takes it in, it breaks it down, and it essentially turns off the signal. What happens with these nerve agents is these nerve agents take up the spots in the enzyme where the acetylcholine neurotransmitter is supposed to go and stops them being turned off. So if they're not being turned off, it means that your muscles are constantly working, and this is what causes muscle spasming or more extremely convulsions. So this is basically what I settled on as being the thing that should do it. There are other culprits that could be at play, but I've settled on this. And the gas, all the gases are very similar in structure in this kind of group. There are some of the examples that there are so Novichok, which is more topical than the others, is a popular amongst the Russian government, allegedly. I don't want to get sued. But that was Alexander Litvinenko was poisoned with Novichok. Novichok is developed in Russia, quite famously. It actually means newcomer, according to Wikipedia. Again, don't always trust Wikipedia, but I don't know why they'd lie. There's also things like there's a V series and a G series, which do sound like Yu-Gi-Oh series, but they're actually not. They're both incredibly dangerous. There's the most famous of this is called VX. VX was developed in the UK, so especially when it comes to nerve agents, I guess it is coming home. And the one that I'm going to focus on, just because it's probably the most commonly known, is called sarin. So sarin gas was developed in Germany in the 1930s. It was developed as a chemical weapon. So chemical weapons were a new thing. I'm going to give you a history lesson for some reason now. Basically, chemical weapons were introduced to win wars. And the reason that they win wars is that they kill people in very small doses. And sarin was developed in the 1930s in Germany and is currently banned under the Chemical Weapons Convention of 1993. So that basically leads you to the conclusion that Haunter is basically a war crime. So I hope that was sufficient in explanation. But basically, I think that Haunter has some kind of neurotoxin in its makeup and is transferred when it licks you. Should also say that sarin gas is clear, colourless, odourless, and also a gas. So it does make sense with the physiology of Haunter. Um, when this was initially sent to me by Toby, he mistyped lick to kick. So at first I was like, how much does it take how does it kick people and they convulse? And then I realised quite quickly what he meant. But I wanted to work out how hard a Haunter would have to kick you. And obviously Haunter doesn't have legs. So I just went for a run into you. It's essentially the same thing. Haunter would have to run into you if it used its entire body. I roughly estimated its height's 1.6 meters. It's very tall. I roughly estimated its width, and it's roughly a triangle. So I just estimated it to a triangle shape. So the rough surface area of the front of Haunter is about 9,000 square centimeters, which is not square meters. It's important to say that. They are very different units wise. Basically, if you do the maths, so force is mass times acceleration. It takes roughly 3,000 newtons per square centimeter to break a bone. Just a human bone. I got this from the internet, so I know exactly how accurate that is. But it's difficult to find the amount of force it takes to kill a person on the internet, which I guess is probably a good thing. So if you do the maths, work it all out, this Haunter would have to hit you astronomically fast to kill you. Like, we're talking much faster than the amount of time, the speed at which the Earth orbits the Sun. And honestly, that doesn't really surprise me all that much, considering it is a cloud of gas. So basically, there's a much higher chance of it licking you to death than kicking you to death. And that is not a phrase I thought I'd say on this podcast. But I guess it is. Yeah, so that's the last one of these. I just thought this would be something a little bit different, a bit fun. There will be guests next week. I've not abandoned guests in any way. I was going to make this into a video, but then I thought it works quite well as like a longer form podcast kind of content thing. But yeah, no, we'll be back next week. We'll have some guests. I won't tell you who they are just yet because I don't actually know which order I'm going to record them in. But there will be one next week. Friday should be out at the usual time of about 5 o'clock. This one will be later as you're listening to it, just because I'm recording this now and it's 5:05, so it won't be out 5 minutes ago. But yeah, thanks for listening. I hope you enjoyed it. If you didn't enjoy it, then it won't be like this every week. But if you did enjoy it and you want to leave me some more questions in the comments, I could do a follow-up. This was fun for me. It's nice to be able to look up some science that I don't necessarily see all the time, and do a little bit of maths on my whiteboard. So yeah, in conclusion, Guzzlord's an abomination that can't exist. Mega Evolution, surprisingly feasible, and Haunter is a floating war crime. So I will see you all next week, and goodbye.